Okay, I think we're all set here. So if anybody has any questions along the way, don't hesitate to type those into the chat. I think I'll see the notification pop up and I'll just answer things along the way. So I think I'll probably be around 20 minutes or so with the content that I have in the slides, just the things that I'm excited about in practice right now. And then we'll have time for Q&A afterwards. But again, if there's questions along the way, don't hesitate to plug those into the chat and I'll answer them as we go along. I am in a lovely little town in southwestern Ontario right now, and the internet connection's okay, but not amazing. So in the event that anything's choppy, this will be recorded and I'll post it on YouTube and on all the podcast platforms and everything as a podcast episode. So hopefully everything will behave well tech-wise. So thank you to those of you who are attending live right now. I appreciate your interest, and for anyone who's listening after the fact, I appreciate your interest as well. I was excited to put this together because there's many things that I'm excited about in practice, but just having a chance to talk about a few of them today specifically, I'm looking forward to that. This the kind of body of the PowerPoint. So the first thing I'm going to talk about is that I've been excited about the research literature and the clinical results that I've been seeing in folks where we've been working on optimizing muscle mass. And I gave a presentation at a conference, I don't know, a few years ago, and it was all about things that can be done to improve a person's not only their lifespan, but their health span as well. So lifespan, of course, is how long you're alive for before you're no longer alive. Health span is how long you feel objectively healthy for before you describe yourself as being unhealthy or on the more infirm end of the spectrum. So, of course, we'd ideally like to have the longest health span and, within reason, a good long lifespan as well. And so these are slides that were extrapolated from that. It's not the full presentation, although as I was going through it and figuring out which slides I wanted to include, I thought it would just be fun to give this presentation again because it's really fascinating. So I might do a future presentation of it for folks if they're interested in that. It's a little heady and it's all about mitochondria, but anyways, I think it's pretty fascinating stuff. So I was kind of disappointed I couldn't give that presentation again because it was fun to put together and fun to deliver it a few years ago. So the slides have been kind of just taken from that presentation. So some of the slides are, way more detailed and getting into the research literature in a deeper way than I would normally get into for a kind of just general presentation. But I'll just kind of give the layperson overview. And if you're, interested in going into more detail, the references are there and all that stuff, and you can geek out as much as you so choose. Just a quick kind of well, disclaimer is not the word. I just saw the word disclaimer, but anyways, a quick overview. One of the things that I'm really mindful about when I talk about optimizing muscle mass is the fact that many of my patients, and I think many of the folks who are interested in, listening to podcast episodes about overcoming chronic illness, they can have a really hard time doing the kind of activity that would help to improve or optimize their muscle mass. And I'm very, very sensitive to that fact and aware of that fact. The reason that I wanted to talk about this is because in patients that I work with who are already generally healthy and we're working on optimizing their health, muscle mass optimization can be really important. Patients who have been dealing with complex chronic illness, but they are, say, 50+% of the way better, this is something that they can oftentimes get into at that stage of their healing process, and it can really help to propel them faster to the finish line of feeling 100% better. And then for folks who are, still in the early stages of their healing process, or maybe they've been working to get better for some time, but they have complicated issues, they're very sensitive to things, they just have really extra complex cases, and they're just at the very early stages of they're like 1% better or less than 10% better or whatnot, or like on their way to feeling 100%. This can still be helpful too. And I've actually had a few cases now, not dozens and dozens, but a handful of cases where, try as we might, like we're having a heck of a time getting much traction with the patient case. And the patient was willing to, say either work with a physiotherapist or occupational therapist or someone where they started implementing a strength enhancing protocol, like a muscle mass enhancing protocol, and it was slow and arduous. Maybe arduous is a strong word, but it was, sort of a not super, super quick process. But as they started doing that, they were getting stronger, and that actually propelled them into feeling better. Because when we have more, and so that kind of got the momentum going, where then we were able to build on that protocol. So certainly this doesn't apply to every single case out there, but it could theoretically apply to any stage of a person's to any stage where a person is on their health path. So anyways, little background there. So in terms of the actual, I guess it was disclosure, not disclaimer, and should have changed it to disclaimer. I always talk about my disclosures when I speak in a professional setting at conferences, and it's always, I have no disclosures because I have no financial ties to any companies or this or that. But anyways, my disclaimer, like I have on all of my videos and podcast episodes, is the content of this presentation is for informational purposes only. It should not be construed as medical advice. If you need medical advice, please speak to your healthcare provider to obtain that advice. I can say that in my sleep. I said it so many times on all my videos. I kept my bio slides in here, or just this one bio slide actually in here. Just I know some folks who listen to the podcast I don't really talk about myself in the podcast because it's about interviewing other clinicians. But if you've been listening to the podcast and you're like, who the heck is this guy that talks to all these amazing doctors that are out there? So I practice in Halifax, Nova Scotia. I graduated about 15 years ago from the Canadian College of Naturopathic Medicine in Ontario. And my practice primarily focuses on chronic infections like Lyme and co-infections, mold illness, chronic pain issues, integrative oncology, which I don't really talk about in my videos and whatnot, but I've treated several hundred patients with cancer diagnoses over the course of time in conjunction with their oncologist and other parts of the members of the healthcare team. Treated hundreds of children on the autism spectrum, many children with PANDAS or PANS, which is this pediatric condition that if you don't know what it is, that's okay. But if you do know what it is, it's really important to know how to treat that. Neurological disorders like MS, Alzheimer's, ALS, things like that, and then basically anything that's chronic or treatment resistant. I treat a lot of chronic digestive issues as well, which I sometimes put that in my bio too, like SIBO and LIBO and yeast overgrowth and things like that. I kept this lecture outline slide largely because I was just so darn excited about going over these lecture slides again. And if there is interest in kind of hearing the full lecture about, more about mitochondria and optimizing health span and lifespan, pop me off an email, let me know, and I'd be happy to do this if there's interest. So the kind of the full lecture that I gave at the conference a few years ago covered all these different topics, and kind of looking into this concept of inflammaging, which sounds like a silly word because it kind of is, but I didn't coin it. But it's the link between chronic inflammation and sort of expediting the aging process, and when people talk about anti-aging medicine and things like that, it's a little bit of a funny term because, of course, aging is just a function of time. You can't change that, at least not to my knowledge. But it's really more about feeling like a person is biologically older than their chronological age, essentially. So kind of making a person feel, like they're, I don't know, 20 years older than they are. But that being said, some folks, I treat 60-year-olds that are healthy. They're healthier than some of my 30-year-olds. So age is just one factor to consider. But inflammaging is essentially this term that speaks to the impact of chronic inflammation on sort of leading to deleterious health outcomes, basically. DAMPS is an acronym for damage-associated molecular patterns, which is something that's associated with poor mitochondrial function can lead to more of this process happening, and that can kind of exacerbate the cellular aging process, shall we say. Inflammasome activation, mitophagy, which we'll talk about in a couple of slides coming up here. Mitophagy is just being that process whereby old mitochondria are broken down and their contents are recycled. And generally, we want to make sure that there's adequate mitophagy happening. Otherwise, there's negative health outcomes that arise. And then the role of mitochondrial DNA. And then I talk about my comprehensive mitochondrial support and a case study and some resources. So anyways, that's a future talk that I could give again if folks are interested. Just a quick note about mitochondria. Again, I should have called these slides more because I know I need to keep it to about 20 minutes here, but just so fascinating. Why should we care about mitochondria? Well, and how does mitochondria relate to enhancing muscle mass? Well, when we have more muscle mass, if a person, say puts on, 2 to 10 pounds of muscle mass, shall we say, then those muscles are filled with mitochondria. As we'll see on the slides coming up, muscles and mitochondria really go hand in hand. And so when there are more mitochondria in the first place, the body can make more energy to begin with. The metabolism's enhanced overall, and we see these, as we'll see in the slides come up here, these significant health benefits. Mitochondria make virtually all of the ATP for our cells. It's really about 90% of all our ATP. ATP being our cellular energy, and we need energy to run virtually all the functions in the cells of our body. So as it says there at the top, ATP makes the world go round. It makes our physiology function. The average person makes around between 24 to 60 kilograms of ATP per day. It's estimated that folks make about one pound of ATP per pound of their, between half to 1 pound of ATP per pound of their own body weight. So just like, wow, we make a lot of energy for us to run properly. Some tissues are up to 42% mitochondria by weight. So you picture like way back in biology class, picture of a cell, it's filled with, there's the nucleus and the endoplasmic reticulum and the lysosomes and all these different things. And then there'll be like, one or two little token mitochondria in there. Well, some cells, it's literally, that picture is like, should be almost half full of mitochondria. Yeah, as it says there near the bottom, mitochondrial dysfunction is a feature of virtually every chronic disease. So that's going to impact our health span. So like, oh, my mitochondria aren't working optimally. I have lower than optimal levels because maybe my muscle mass isn't where it ideally should be. Well, then you're going to be more prone to chronic illness, and that's going to impact your health span. How long am I alive for before I start to feel unhealthy or infirm? And then the final note there is mitochondrial dysfunction appears to affect aging and ultimately our lifespan. So super, super important. Just a couple little slides here, and then just indulge me for one more minute, just so I can show these very exciting slides about mitochondrial fun facts. If you look at the highlighted areas, it's basically showing the percentage of the entire cell volume that's occupied by mitochondria. So we see there at the top, the liver cells, 27.5% of your hepatocytes, your liver cells, are filled with mitochondria. It's like, wow, how fascinating is that? We talk about how important the liver is for detoxifying things and whatnot, processing hormones, et cetera, making proteins and blood clotting factors and various things. And well, those liver cells need a lot of energy to function properly. So when folks come into my practice and they're really tired, it's like, okay, your cells aren't cranking out enough energy. Well, of course, that's going to have a negative impact on the efficiency of your liver processes because they need energy to run. Yes, they need B vitamins, they need glutathione, they need conjugation factors like, taurine and glucuronic acid, all these different things, but they actually also need the energy to run the engines as well. A third of their volume, give or take. Well, I guess a little better than a quarter of their volume is made up of mitochondria. That's really notable. Same thing with the kidneys. The second highlighted area down there, about 38% of kidney cell volume is mitochondria. So again, liver, kidneys, super important for detox, for lots of other things too. And then the heart, almost half of the volume of the heart is made up of mitochondria. So really, really relevant. And then just a sort of similar but different chart here, looking at the overall amount of energy expenditure in the various tissues of the body. So what we looked at on the previous slide is when you take a given cell, heart muscle cell, liver cell, what have you, what percentage of it is made up of mitochondria. But when you look at the overall energy expenditure for a person when they're at rest, so, not when they're doing a calculus exam, not when they're running a marathon, but they're just kind of, going about their, like they're just resting or just having like very light activity, shall we say, then about, as it says there with the little parentheses, about 22% of all of our resting energy is used up by our muscles. So more muscle means more energy expenditure, means more energy production in the first place, also means a higher metabolism as well. 21% by the liver, and then 22% by the brain. So, what are the tissues that are going to be the most impacted if our mitochondria aren't working optimally? It's the muscles, the liver, the brain. I mean, everything, but those, proportionately more than others. So not a surprise that when our mitochondria are struggling, we feel tired, we get brain foggy, and then it's a little more in the background, but some of these important liver functions can also start to deplete as well. So I mentioned that this process of mitophagy is really important. So again, we want the old mitochondria to be broken down and essentially recycled. And if that process isn't happening because the body's just not getting the signals to do that, then it can lead to negative health outcomes. So we'll just kind of gloss over some of these slides because, again, I just kind of cut and pasted them and kept in yeah, all the more heady details here. But essentially, if we look at the top quoted line there from this study that's referenced at the top, if anyone wants to look into this or fact check it or whatnot, these are all just direct quotes. But there's evidence that autophagy plays important roles in health, lifespan, and health span in mammals. So autophagy is sort of similar but different to mitophagy. Mitophagy is the breakdown and recycling of old mitochondria. Autophagy is the breakdown and recycling of entire cells, including the mitochondria contained within there. And so the second bullet point there basically says that when they do these mouse models, so they kind of delete certain genes, and poor little critters living in labs and whatnot. But if they basically delete this key regulator of autophagy, which again kind of different but very much related to mitophagy. So when they delete this gene in mice, then the sorry, my grandmother's air conditioning just kicked in. I hope it's not loud. It's just a little buzzy here in the background here. When they basically interfere with that function of autophagy, then the mice that they do that in have severe muscle atrophy. So like, lower muscle mass, not good. Deterioration in neuromuscular junction, so interfering with the sort of overall functionality of those muscles, and then also a reduced lifespan, also not good. And they also found that then when there was this overexpression of that exact same gene, so in other words, like when they knock it out, less muscle mass and reduced lifespan. When they start to overexpress it, so they kind of manipulate the genome of the mouse to have an overexpression of that gene, so there's more sort of more optimal function of that autophagy. Then even when they did that in aged skeletal muscle fibers, then it actually restored the autophagy function and actually increased the integrity of those neuromuscular junctions and increased the myofiber size, so muscles got bigger. So just kind of speaking to the fact that regulating that autophagy related gene is very important, and that autophagy and kind of mitophagy by extrapolation are important. Whoops, easy. And then final bullet point there, I'm just indicating that when there are mutations in that gene, then it can have cause neurodevelopmental disorders, including neurological, muscular, and endocrine hypofunction. Endocrine hypofunction meaning suboptimal function of the hormonal systems in the body, and how many folks with whether they have complex chronic illness or not, by a certain point in time in their life, it's like, oh, I'm having issues with, sex hormones, adrenal hormones, thyroid hormones, etc. So really, really important to make sure that autophagy and mitophagy are working well. Just more evidence here or information here. Oh my goodness, I guess I have a auto bullet point generation, I think here happening. Okay, there we go. Now it's behaving. So in C. elegans, earthworms, basically, when they inactivate autophagy, then there's a decreased lifespan for those worms. Similar with kind of the opposite with Drosophila, which are fruit flies. When you promote autophagy, it extends their lifespan. And just gonna basically just more points, kind of saying the same. Right. So, so here we're seeing that from this paper that the level of mitophagy, so talking about mitophagy now more specifically than autophagy, but again, very much overlapped, it declines over time during just the normal aging process. So this is, to my understanding, one of the reasons why folks, generally look and feel different when they're, say, in their 60s or 70s compared to when they're in their 20s or 30s. There is this normal sort of age appropriate, age expected decline in mitophagy. However, as we'll see coming up, there are things that can be done to sort of slow that process, or in some cases kind of reverse that process. Let's see here. Okay, so essentially, if there's suboptimal autophagy going on, then person's going to develop more dysfunctional mitochondria, which are going to lead to different issues. So it's like, well, why is mitophagy important? Why is autophagy important? Well, ultimately, we don't want that to lead to mitochondrial dysfunction, which, talking at the start about how important mitochondria are for many different tissues. Just a little schematic here. It's nothing too earth-shattering, but if we kind of follow the top, and what should happen with a healthy mitochondria is when there's stress, which we'll talk about some of those stressors coming up, then that will lead to mitophagy, and you remove the damaged mitochondrion. So and then it's recycled and things are good. Whereas with the aging process, there's going to be this reduction of mitophagy. You're going to accumulate these damaged mitochondria, and then you're going to see elevated ROS, which are reactive oxygen species, also known as free radicals, also known as the opposites of antioxidants, decreased bioenergetics, i.e., not making as much energy on a cellular level, and then this increase in age-related pathology like neurodegenerative conditions and things like that. So, how can we encourage mitophagy? So ultimately, and I'll just kind of go through these slides a little bit quick. I'll get all the notes up in case anyone wants to go back and, oh my goodness, it's a hair trigger here on these slides. So the gist of it is that exercise leads to, of course, increased muscle mass, but it also encourages autophagy as well. Another thing that can have an impact, this is a little bit off topic because the thing I'm excited about is the building muscle mass, but just thought I'd include this for the sake of completion. Calorie restriction is also something that's been shown to help enhance mitophagy. So for anyone who listens to or reads information from folks who are biohackers or who talk about sort of like health lifespan optimization, it's probably not a surprise to hear like, oh, exercise is important. Oh, calorie restriction is important, because we know that overeating is not good. But it turns out when we intermittently reduce calories, that is also something that has an overall health benefit. Because if we go back to the previous slide, that relatively simple diagram there, as it says at the top, stress leads to mitophagy. Well, what are these stressors? Well, exercise is a stressor, of course, or well, depending on the exercise, if it's light enough intensity, maybe it's not really stressful at all. But if we're doing exercise that's going to lead to muscle building, why do muscles build? We lift heavier things or do body weight exercise or whatever it is that puts strain on our muscles, get these little micro tears in the muscle, which is why the muscle gets sore afterwards or hits a limit. And then the body heals it and it comes back stronger than before because the body realizes, oh, I guess we're lifting heavy circular metal discs or kettlebells or doing jump squats or whatever it is. And so the body comes back stronger from that. So that stress could be exercise. That stress could also be caloric restriction. So if the body sees that, oh, I needed this many calories, but this person that I'm attached to is intermittent fasting, well, then that stress is going to also activate some of these mitophagy and autophagy pathways as well. So just a little reminder note that calorie restriction is something that will enhance mitophagy as well. Now, especially in folks who are dealing with complex chronic illnesses, or health issues, we do need to be really mindful. At least in my practice, I'm very mindful about when I recommend calorie restriction. And folks sometimes hear calorie restriction as like, oh, look, I'm going to do really intense intermittent fast, or I'm going to do multiple day water fasts or whatnot. That can be a good fit for some folks, but sometimes it's a really, really bad fit. So when a person's body is already quite depleted, when there's already that impaired mitochondrial function happening, sometimes the body just does not have the resources to kind of weather the storm of the calorie restriction, and a person just feels more tired, more crummy. So it's something that definitely should be cautious with it in general, but especially if there are underlying chronic health issues going on. Okay. Sorry, folks. I included too many slides in here. I was too excited, but I'm going to just skip through these here. It's kind of just a note basically saying that as folks, as part of the normal aging process, there tends to be this reduction in mitochondrial density, but with exercise, one can mitigate or reverse that. Just a note here, sarcopenia is this term that describes basically loss of muscle mass overall, like not just muscle shrinking, like I had these big beefy biceps and I haven't lifted weights in a while and now they're no longer big beefy biceps. It's actually a loss of muscle tissue, and that's actually as it says in this slide and maybe some subsequent slides here, that sarcopenia, that loss of muscle tissue, is a big predictor of folks having notable health issues, and it directly relates to a person's lifespan, where if we have more sarcopenia, it tends to lead to a shortened lifespan, which, based on everything we've been talking about so far today, makes a lot of sense because muscles / mitochondria, very important. All right. And just the last point there that's highlighted from this study. So the most efficient interventions to attenuate, i.e. reduce sarcopenia, that muscle mass loss, are exercise training and calorie restriction, both well known to improve mitochondrial health. And I always have this silly thought that like, oh, maybe my presentation won't use up the whole 20 minutes. So I better, make sure I have some extra slides in there. So in the event that we somehow magically don't have enough to talk, or there's not enough to discuss during this presentation, I'll come back to this case report. But the punchline is that patient with chronic health issues felt a lot better after we got some comprehensive mitochondrial support in the mix. But I'll circle back to this if there is time. I included the learning resources slide here just in case folks are interested in learning more about mitochondria. One of my naturopathic colleagues, who I don't know, it's funny that his name is Lee No. I don't know Dr. No. I'm sure there's probably a funnier thing I could have said there. But anyways, Dr. No, who I don't know personally, but wrote this book called Mitochondria and the Future of Medicine. It's a really, really great book. When I first started becoming obsessed with mitochondria, it was one of the first books that I read. And it's just a really, really great overview of mitochondrial physiology and health. But like it's very much kind of written to like a general public level, but it still goes into like plenty of detail. But I think it's just a really, really well written book. So anyways, if you're interested, take a gander. Dr. Sarah Myhill, she's a medical doctor. I can't remember what the acronym MB stands for, but an MB in England, where she's from, is equivalent to an MD here. So there's this book which I think is have a very clever title. The subtitle being it's mitochondria, not hypochondria, because it's a book all about chronic fatigue syndrome. It's I think very, very well, it's a very, very good title. And so that's another book that's written for the general public, but does get into like quite a lot of detail as well. Please don't go to consultdranderson.com because it's just continuing education courses for clinicians. Go there if you want to, but I think you have to be a clinician to register for the webinars and all that. And anyways, Dr. Anderson's a brilliant guy. By all means, consider following Dr. Anderson on Instagram. He's on, I think he has YouTube videos as well. He's one of my mentors. He's been practicing for 40 plus years. He specializes in complex chronic illnesses and oncology, actually. And so brilliant, brilliant guy. And then there's this review course, which is also for clinicians only by Dr. Walsh. So that's the learning resources there. So I'm just going to take a quick sip here. Right. So the second thing that I am excited about in practice right now is something referred to as brain mapping and neurofeedback. So for anyone who may have listened to my interview with Dr. Jabin Moore, which I posted maybe a month or so ago, he's a chiropractor from Kansas City, Missouri. We talked about neurofeedback, and after that conversation, I just really got a bug in my ear. But like, I need to look into neurofeedback and brain mapping. I had heard about neurofeedback and brain mapping years and years ago. I looked into it. It was very, very expensive back then to get set up with that, and it just wasn't an option for my practice at the time. But after talking to Dr. Moore, I looked into it again, and while they're still not giving away the systems that are out there, they are some of them are markedly better priced than they were once upon a time. And so I've recently taken the plunge in bringing in brain mapping and neurofeedback into my practice. It's about 50 hours of training. So I'm plugging my way through that and all of my, non-existent free time, and a lot of, just practice scans and things like that. So I'm not using this in practice yet, but I wanted to talk about it because I've been, very excited to the point of bringing it into my practice. And so I thought I'd talk about that quickly here. So with brain mapping, and thank you to Scottsdale Neurofeedback for putting up this image, which there's the credit for this image. I'm sure it's a lovely website. I just have the link there because I want to give credit for the image. So with brain mapping, hopefully my face isn't covering up the best part of the picture, which is the glorified shower cap that's on the little guy's head there. So I'll move that. I don't know if it'll make a difference in the actual recording or not. But basically with brain mapping, person puts on a glorified shower cap, similar to what's depicted in the picture there. Oh, something in the chat here. Oh, okay, great. Thank you for letting me know you can see the cap. That's perfect. So we put on this glorified shower cap, which is hooked up to 19 electrodes, which read the person's brainwaves. So it reads the brainwaves. It doesn't put any energy into the person's head, so there's no shocks or anything like that. It's just reading brainwaves. And it's the exact same technology that's used to scan a person's brain to see if they're having seizure activity. It's just measuring brainwaves. Excuse me. But the this type of EEG is actually a quantitative EEG. So the quantitative EEG is actually quantifying the amount of the different types of brain waves at the different regions in the brain. So the computer software, which looks like he's watching a video or something like that, not that's and then the other picture, the other computer looks like it just has a lovely screensaver image there. But what we'd be seeing if we were actually doing a scan would be just all these little kind of looks like an EKG, like if a person's getting their uh, like an EKG run on their heart to see like how the heart rhythm is doing and whatnot, kind of seeing like the little wavy lines. We kind of have those for all of the different wavelengths that the brain can express. So the delta waves, theta waves, alpha waves, and beta waves. And so we'd be looking at that on the other screen, and basically the computer software would be recording or quantifying all of those brain waves. So after doing the scan, which depending on the system that's being used takes anywhere from say a couple of minutes to say 15 minutes, then the computer software essentially creates a brain map, and it tells us, are there any areas of the brain that are overactive or underactive? And if we see that the areas of the brain that are underactive or overactive are correlated with the types of symptoms that the patient's experiencing, then we know, okay, there seems to be a brainwave imbalance that's related to their health concerns. And there's a subsequent treatment called neurofeedback that we could work with in a targeted way. The way that we see if there's that correlation is, you have the brain map, and the patient fills out a couple of questionnaires, just asking them about physical symptoms they're having, kind of any mental emotional symptoms that they're having. And then the computer software kind of pairs that up essentially with the brain map. And then we see, oh, this person's having issues with insomnia. And the part of their brain map that would be associated with insomnia is also off kilter. So therefore, brainwave imbalances could very well help to explain why the patient's having issues with insomnia, and rebalancing those brainwaves could lead to a improvement or resolution of the insomnia. Whereas if we saw that, oh, the patient's having migraines, but the migraine part of the brain map looks okay, then it would mean it would be quite unlikely that working on the brainwave rebalancing would have a positive impact on helping to improve or resolve those migraines. So with neurofeedback being the training or the treatment for that, if there are these brainwave imbalances, we get this not only a brain map, or the brain map doesn't only show us which areas of the brain might be kind of overfunctioning, underfunctioning, but the computer software also gives us good prognostic information about, is doing the subsequent neurofeedback training actually, plausibly going to help those symptoms. So say the person who has migraines, but their brain map doesn't look like a migraine pattern there, well, then maybe their migraines are, quote unquote, just due to, mold toxicity, or just due to vitamin B2 deficiency, or just due to magnesium deficiency, or stress, or whatever it is. Although stress would probably pop up as brainwave abnormality. So scratch that one. That's not the best example. So that's what the brain mapping part of the conversation entails. So if it looks like the brain map, based on the brain map and based on the patient's symptoms, that there is something matching up there, then we could say, okay, let's do some neurofeedback to retrain those parts of to train those parts of the brain to display the types of brain waves that we want to be seeing. So let's see how my next image looks here. Oh, right. So just before we get to the neurofeedback, so just a picture from one of the brain mapping programs. So there's different ways of kind of expressing the results with the images, but this would be an example of like, oh, we can see at the top there, like the top row of heads, that's before neurofeedback. And generally we'd want the color scheme to be kind of in the white or green or very light blue range. So at the top, you can see like there's lots of red, which is not optimal. And then, after doing the neurofeedback, then like, oh, look, we're seeing, the color scheme looks a lot better. We're not seeing like as much of the red in this particular case. So you can see these before and after. So generally do the brain map. If neurofeedback is indicated, you do the neurofeedback. So you do several sessions of that, and then repeat the brain map and see how things are looking. And the areas that are being worked on, we should see improvement there. And a really cool thing with neurofeedback is even if you're working on, say, areas that are just say around the forehead, for example, like working on that prefrontal cortex, due to the extreme intricacies of the brain, shall we say, a very, very complex system there. Even just regulating those areas can have an impact on other areas of the brain too. So the person who these brain maps belong to, they may have just been doing neurofeedback around, say the top of the head, for example, and yet it's had a spillover effect throughout their entire brain. So it's pretty cool stuff. All right. So with neurofeedback itself, I guess I could have kept the other image up, but with neurofeedback, if say we found that there was say not enough alpha waves in this area of the brain, and there were too many beta waves in that area of the brain, and that was plausibly connected to the chronic fatigue the person's having, the PTSD that we know they have a history of, the anxiety and insomnia. Like there's say several symptoms linked to this kind of brainwave imbalance. We say, okay, well, we want to increase the alpha where it's too low and decrease the beta where it's too high. So how are we going to do that? Well, we do that through neurofeedback. So in this case, and again, probably should have picked a different image, but this person is, sitting there watching this video or game or whatever it is that's happening, like with a race car. And so we can't see it on the picture here because actually it looks like they're not actually hooked up to any electrodes at all. But the little box on the table there with the different electrodes coming out of it, a couple of those leads would be attached to a couple of different regions or areas of the person's head. So if we wanted to work on the prefrontal cortex, we put those electrodes on the forehead at the right locations. If we wanted to work on the temporal lobes, we put those kind of above their ear in a certain area. So between 2 to 4 electrodes would be attached, not the full glorified shower cap, but 2 to 4 electrodes would be attached. And then we tell the computer software, okay, in this example, we want more alpha over here and less beta over there. Wonderful. So then the computer software will be scanning those areas of the brain, and the person's either watching a video, like the person in the picture here, or they'd be sitting with their eyes closed listening to music. And if the brain is exhibiting the brainwaves that we want, so in this case, more alpha, less beta, then the video is going to play at full color, the music's going to play at normal volume, and the brain's happy because it's getting little dopamine hits from that. Brains really like watching stuff, which is why people binge watch Netflix, and brains really like music, which is why people like music, amongst other reasons. But if the brain then starts displaying brainwaves that we don't want, so it's getting some theta in there, or it's getting some delta in there, or it's there's too much beta, not less beta, it's basically not doing what the computer software wants it to do, then the screen is going to dim so the person can barely see the video. The music's going to be much harder to hear. Like the volume's going to go way down, and the brain's going to say, wait a minute, I was watching that, I was listening to that. And because it's not getting its dopamine hits anymore. So then the brain will start cycling through different brainwave patterns. And once it gets back to doing what we want it to do, more alpha, less beta in this case, then the computer software is going to pick that up and it's like, oh, good, brain's doing what we want it to do. The brightness of the screen goes up, the music starts playing at normal volume again, and the brain says, aha, I'm getting my dopamine again. But then once it slips into its old pattern, then the screen dims, the music goes down, and then the whole cycle repeats itself. And so basically over the course of time of doing neurofeedback, the brain is essentially coerced through this operant conditioning to start displaying the wavelengths that we want it to be displaying. And so once a person does enough neurofeedback training, then it's like, oh, now my brain just has less beta on average in general. It has more alpha in this region in general. And now my sleep is doing better. My anxiety is less. My migraines are better, whatever it is that we were working on. So that's the whole method to the madness with the neurofeedback. As I said earlier, after doing a certain number of sessions, we do another brain map, see how things are looking. But that's brain mapping and neurofeedback in a nutshell. So it's something that in my clinic, if my prognostications are correct, probably by mid-August we'll be up and running using this with patients. And then in the subsequent months, I will post videos about it on social media. I'll mention it in the newsletter, maybe have another live Q&A/presentation at some point and talk about it in more detail. But it's something I'm really excited about as I've been learning more and more about it, and just hearing about clinical feedback from, like, now I'm part of these neurofeedback brain mapping communities and clinician networks and whatnot. It's like, oh my gosh, I really wish that I had been offering this years and years ago. but we'll see how it works out in my practice as well. So the very last topic I wanted to mention, and for folks who listen to my social media content or whatnot, or access that on a semi-regular basis, but probably not surprised to hear me talking about cold plunging. I hope it's not too predictable. Just going to move the little icon here, which apparently I can only see and no one else can see, but it's in the way of the list that's going to come up here. So I've been very excited about cold plunging. I've been yapping about it for probably the better part of 4 months now on social media. Pretty much at the point where, like, if I don't get to do it every day, I'm a little bit disappointed because at first it was like, okay, I'm going to do it twice a week because, like, oh, I got to try this. And now it's like, oh, like, where's my cold exposure? So I'm getting a little bit addicted to it. I have this picture up here because, in part because the Huberman Lab, excuse me, Huberman Lab podcast is fantastic. If you're not familiar with it, Andrew Huberman is a PhD researcher from Stanford University. My understanding is his labs mostly revolves around human, like, performance, like human biomechanics and things like that, and like sports performance and exercise physiology. But he talks about a lot of really fascinating stuff that extends on his podcast, that extends far beyond those topics. A lot of kind of quote unquote biohacking topics and things like that. So this interview that he had with Dr. I think it's pronounced Sjoberg, I can't remember for sure. It was put out maybe within the last couple of months anyways. So it's a really great overview of cold plunging. And I really like Dr. Huberman for many reasons, not the least of which is that what he talks about is all very heavily evidence-based. So he really, unless it's talked about quite robustly in the research literature, he doesn't seem to really talk about it. So I like that because my left brain, my scientific brain is gravitates towards that. And then also he practices what he preaches. So he does cold plunging himself. He does, he tries the exercise regimens that people talk to him about on his podcast, and dietary things and supplements and this and that. So he's not just looking at it academically, but also experiencing it too. So it's a great interview, and some of the just bullet point take home messages here from cold plunging, in no particular order, are that, to my understanding from the research literature, seems like the optimal benefits from cold plunging are achieved doing about a sum total of 11 minutes per week. So a lot of folks will do that as, say, 3 minutes of cold exposure, say 4 times in a week, but one could do it differently. Another take-home message with cold plunging is that the goal of it is to feel cold. So one of the things him and Dr. Soberg talk about, and other folks have talked about too, is like, oh, like, what's better? Like, should it be 10 degrees Celsius, which I think is 50 degrees Fahrenheit or something like that? Is that the water temperature the best, or should it be 15, or should it be, should I need to be like breaking the ice on the top of my cold plunge because it needs to be as close to zero as possible? To my understanding, the goal is to feel cold. And if we think back to that slide about the mitophagy, where stress ultimately leads to more mitophagy, it makes sense. If a person is not acclimatized to cold exposure at all, something like even a 15 degrees Celsius cold exposure might give them all the health benefits that someone who's acclimated to cold exposure might get at, say, 5 degrees Celsius water. So, i.e., very close to freezing. So the goal is to feel cold. And it was great for me personally when I heard that for the first time, because I was kind of a bit hung up on the numbers. I'm going to make a video and I'll post it on my YouTube channel at some point, just showing my home setup with my cold plunging. But the long story short there is that I'm not using my cold plunge in the warmer months here, like in late June, July, August, pretty hot in Nova Scotia. And it's just I didn't want to get a water cooling machine, nor did I want to buy an ice machine and dump, like, I did the calculation, I need like 30 kilograms of ice or something like that for every cold plunge. I'm like, I really don't want to spend the energy and environmental resources on that. So I've just been settling for cold showers in the meantime, and I seem to be getting by with that well enough. I haven't wasted away, thankfully, not having my proper cold plunge. But when I first started out, I was like, oh man, like, it's getting warmer outside. Like, my cold plunge is only 12 degrees today. Like, is that going to be good enough? And really it was about, like, did I feel cold? And the answer was no. So I started, putting ice blocks in there and just, kind of like moving around and, kind of putting the ice on different parts of my body and whatnot. And, like, it was really unpleasant, but it made me very cold. And then, I feel like, oh yeah, I'm getting those health benefits, even though the water itself maybe isn't, quite where it should be. So the goal is to feel cold. And so whatever that means for a given person, as long as you're feeling cold, that's the key. And now I embrace the cold. It's like, oh, right. Like I want to feel cold because I want to get those health benefits. Just another important point that I don't remember if Dr. Huberman talks about this in this episode, but he definitely has in other at other times where, to my understanding, it is important to wait at least 4 to 6 hours after exercising. If, not shoot, I should probably edit that, but wait 4 to 6 hours after exercising if the goal is to try to build muscle, which in the theme of today's presentation, maybe that's something folks will want to be doing. My understanding is if you do cold exposure prior or with less than 4 to 6 hours post exercise, then it can actually minimize some of the expected kind of wanted local inflammation in those muscles that's ultimately sending the signal that, like, hey, we need to build bigger muscles here. So it could actually lead to a reduction in the muscle gains that one's looking for. So it's like, oh, I just, hit the gym really hard and then now I'm going to go into an ice bath. It might feel good afterwards, but it's could have a negative impact on the outcomes of that exercise. So for me, when I do my resistance training, if I'm going to do a cold plunge that day, I'll do it in the morning before I lift. And I've done it where I do the cold plunge and I lift weights within 15 minutes of that, because timing wise that's what worked out, and my understanding is that's totally fine, but just not wanting to do it after the fact. One of the benefits of, or I should say some of the benefits of cold plunging, are that it increases brown fat, so brown adipose tissue, which helps to make us more resilient to day-to-day cold that we experience. So cold plunging can make it more comfortable and easier to enjoy outdoor life in Canada and other northern climes, but it also increases our metabolism overall. It's also been shown to boost dopamine notably, and speaking from experience, when I get out of my cold plunge or nowadays cold shower, I'm a generally happy, upbeat guy, but I just feel like that much better. My mood's better. When I miss my cold plunges, I'm like, I just feel like, I'm still good, but it's like, I just feel like I'm missing a little something. So it does seem to be good for dopamine, and I'm thankfully not prone to or a victim of like addiction or things like that. But I feel like for folks who, like, to my understanding, folks like if they have low dopamine propensities, like say folks with ADHD, or if there were like issues with addiction, whether it's to illicit substances, alcohol, food, gambling, whatever it happened to be, things that are going to boost dopamine naturally could be really helpful to kind of break some of those patterns. So some of my patients who have struggled with saying like, I know I should be following this type of diet, but man, like just I'm really hooked on that sugar, for example, like cold plunging has been helpful for some of them to kind of break some of those habits or whatnot. And then of course, most importantly, when you cold plunge, it just builds lots of street cred, which is why I do it. It's really not for the health benefits. I just want to be able to go around saying, oh yeah, I'm a cold plunger. Just see there's a question here in the chat or something in the chat. So the question here is, does being outside long enough in the winter to make you feel cold suffice for giving you the same health benefits as plunging? It's a really good question. I feel like during this episode of the Huberman podcast with Dr. Soberg, that like there were submitted questions that Dr. Huberman had accumulated ahead of time, and like a lot of them, he was like, so many people are asking like, does this count? Does this count? What's better? Like, is this better or that better? Is a shower better than a plunge? And can I just go outside in the snow and blah blah blah? And the take home message seemed to be, they have not studied all those different methods independently of one another. So it's very much based on putting together common sense and just opinion. So we don't know for sure because it hasn't been specifically studied. But the take home was just feel cold. Now, with that being said, if a person's, outside and they're like, oh, I'm just kind of underdressed and I'm kind of just gradually feeling like colder and colder. I'm stuck outside for 2 hours or something, and I'm just gradually getting chillier. I do wonder if that wouldn't be as impactful as like I went from feeling normal to like now I'm in a 5 degrees Celsius cold plunge. I feel like the more like immediate, short-lived, like kind of shocking type cold, if you will, would probably have more health benefits because it's more of like an immediate stressor that the body has to respond to as opposed to like a prolonged stress. But I don't know for sure. So I think the official answer is feel cold, and that's probably going to do the trick. But if it was like, oh, can I just go out and like what I'm planning to do, because my cold plunge is outside and I don't plan to bring it inside. So when it's too cold and my water is frozen, I'm not going to throw like little lumps of hot coals in there or something like that to warm it up a bit. I'm planning to just go outside and like, say, my bathing suit and just, make my neighbors think I'm even weirder than I am and just see me outside, in the snow or whatever, just getting cold out there. But I'll, set my timer and whatever and just, yeah, get chilly for a few minutes. So I think that would be just as good. I don't think it has to include water. You are welcome. All right. So I was meaning to get a little timer. What time is it? Oh, there we go. Okay. Oh my gosh. Well, anyone who's participated in my live recording of my overcoming chronic illness course is probably thinking like, I'm not surprised that he thought it would take 20 minutes, and here it is almost an hour later. So thanks for your patience, folks. Hope nobody had plans that this interfered with. But that is the end of the presentation. There were a couple of submitted questions, but I will open it up to any other questions from the audience here, just as I'm talking about or just mentioning some of the places you can access me online. So please feel free to plug those into the chat. If you have a longer question you want to type out and just need a minute to type it out, just say questions coming, and I won't end the webinar or the presentation prematurely. So just feel free to plug that into the chat. If there are other questions and you're like, I don't really want to ask this in this medium, but you want to ask otherwise, you can always email me. If everyone on here live right now is I know subscribes to my newsletter, so you can just reply to any newsletter and it'll go right to my email account, and I'll answer the question on a subsequent social media post. But yeah, places where you can access me if you're interested in seeing my posts. I put all the same stuff on all the different platforms. So if you follow me on Instagram and that's your social media of choice, you can follow me anywhere else you want to, but it's all going to be the same content. So just my Facebook handle is East Coast Naturopathic Clinic. YouTube is Halifax Naturopathic Doctor. Instagram is dr.bryanrade.nd. Website is eastcoastnaturopathic.com if you want to access our clinic and see what's on there. The podcast is Overcoming Chronic Illness Podcast, which if you're listening to this on the podcast, you already know that, but if you're watching this on YouTube or whatnot, that's the name of the podcast. And then just a little side note, I do have I just call it my pet project here. I started up a registered charity a couple of years ago, and the websites are listed there. One's madelocalgroup.ca for Canadians and madelocalgroup.com for folks from the US. Of course, anybody from any country can access them if they want to. But basically, it's a project where these websites are promoting folks who are making products locally in Canada or in the United States. I won't go on my soapbox here right now, but basically, to my understanding, when we are able to purchase goods that are manufactured locally, then it's good for the local economy. It creates jobs in the local economy. It has reduced environmental impact if we're not shipping things from all across the countryside or all across from intercontinentally and whatnot. There's some other benefits too, I think. So anyways, if you're interested at all in buying things that are made locally, we've been adding listings for a couple of years now. And but that being said, we keep finding more listings. So if you know of companies that manufacture goods in the US or Canada and you don't mind taking a minute to share those with us, feel free to send it along. You could check the website first to see if we actually have them listed, but if not, that's okay. I have someone working for me adding listings. So if she sees, oh yeah, we've already got that one, that's okay. But just a little plug for that. Just a couple things in the chat here. And okay. Yep, you're welcome. Yep, and okay, looks like no questions, but yeah, appreciate the love. I'm glad folks enjoyed the content today, and I think we are at time. So thanks so much to those of you who attended live, and I hope that it was useful for you. And to those of you who are attending or accessing the information after the fact on social media or via podcast platform, thanks for your attention, and I will leave it there for now.